Hello. Today I'm going to talk to you about metamodeling, what that is, and how metamodeling can be classified. So you will see what the metamodeling is, how is it applied, what is the motivation for using it, how metamodeling can be classified. We will see an example, and we'll conclude with a summary. And what I want you to know by the end of this talk is what the metamodeling is. Yes. What is the motivation for using it? Why do we need it? And how it can be classified. So these are the three main features we're going to focus on. So what is metamodeling? Metamodel, or sometimes called surrogate model, is a model of a model. In other words, this is a simplified model of an actual model. And metamodeling is the process of generating such metamodels. So let's take an illustrative example. Let's consider some function f, which we will call a true response function. It can be anything. We may not even know it, but it can be provided by a theory that we have, and we will have an error epsilon, which will have an expectation 0, meaning on average it will vanish, and we will take the input or the argument will be considered on some domain, and I will say later why it's important. And this will give us some output y. And so, as I said, because the error that is there, it's just there. It can be whatever we measure. Any system that we have, it will contain an error, some statistical error. As I said, the expectation is 0, so on average it vanishes. So if you take the average of y, we will just end up with the f, right? And we can approximate our f, which is our true response function, with some function g, which is our metamodel. So here how can be viewed. So we have some set of points y that we have, maybe from testing or whatever. These are the true realization. And this red line is the function f, right, that our theory provides. And we will approximate it on this interval from a to b with our metamodel. See, this is important. What I want you to know that g is an approximation of a model f that our theory maybe provided us with, and it has to match the true response function, the model, on the certain interval that we limit ourselves to. Okay, so and in this context, metamodeling can be viewed as a curve fitting, right? When we have just one a function of one variable x. All right. So where is it applied? In engineering design optimization, in mechanical engineering, in software engineering, in systems engineering, and many more. So what I want you to remember is that metamodeling has a very vast application. But we will limit ourselves just to mechanical engineering in this talk. Why do we need it? The most common answer is just to save time, to replace the computationally expensive procedures with something faster. So an example can be to compute contact pressure between two bodies using the Hertzsprung theory. And you don't have to understand any of it. It's just to give you an expression that during this computation you will have to solve this complete elliptic integral of the first kind. So this evil thing will have to be solved iteratively for k, right? And we don't want that. So in order to spare time not to solve it iteratively, we'll try to construct some analytical expression that can be inverted. I mean, something you can solve quickly, right? So instead of having this complicated expression, we can have something simpler. We want to. All right. So how can we?
What about the accuracy?
Yes. So we will try to, of course, to minimize the error. To preserve. So we will try. We will as I said, we will have a number of points, right? If we go back here, you will have a number of points of realizations, right? And then you will try to construct your function so the error between these green dots is minimized, right? Or,
is it between the green dots or between the lines?
Red
well, the red
and the
is is essentially between both, because we're talking the average, right? And we're just eliminating the error. But we keep in mind that there is error, but we cannot get rid of that error. We just, so we approximate the model, but we will have the maybe the realization of the model, or maybe if it's unknown, we can have the just realization of our measurement, whatever we measure. All right, yes. Let me check the time now. So, okay, yes. So metamodeling, how can we classify it? So metamodeling, it involves the following techniques, and this is just the phrasing that is used in the literature. Maybe you can think of steps that are used in the metamodeling. So we have to choose our sampling method. So how we can sample our input data. There are several examples. You don't have to concentrate on that. The second step would be to choose a model to represent the data. It can be also something. And the third step will be to fit the model to the observed data. Right? So we have 3 steps, and they can differ. And what I call a metamodeling method will be a collection of these 3 steps. So say I choose the sampling method to be a central composite design. You don't have to understand what it is. Just you pick something, right, for a sampling method. Then you have a model, which can be polynomial, and the model, the fitting is done with the maybe least squares method. Then this collection of 3 techniques will be called response surface methodology. Another example can be kriging, which will have a different number of techniques, a set of techniques. So what I want you to understand now is that the classification relies on a particular choice of metamodeling techniques. Is that clear? We classify based on which metamodeling techniques are involved. Okay? Is it clear or is it not?
But can we choose CCD and realization of stochastic and least square regression?
For now, you can think yes. You can you just, all you need to know that we pick something in the first step, we pick something else in the second step, and then in the third step, and then yields one method. If we have a different choice in the first and second and third step, it will be yet again something different.
So this is not written on the stone. This you can evaluate
Yes,
and decide.
yes, you can. Well, maybe there will be still some overlaps.
Yeah.
Like whatever, if you choose something different, it will still be response surface methodology. It can be true, but I mean the concept is that yes, you differ the steps, the choices for the steps, and then you yield in another method. Okay. All right, so how can a surface methodology look like? And here's how. So we will have some realization. Maybe if the function is known, provided that's the most usual case, that we have a theory, but it's complicated. You've seen, right, with the elliptic integral. It's an evil thing, it's very large, we don't want that. So we have a number of realization within our domain, whatever we choose. Within our domain, we realize it a number of times, and then we construct a polynomial. So this is the model, right away. This is the model. We choose a polynomial for the model, and then we find these coefficients for the polynomial using the least squares regression. So that fitting, the third step that I mentioned, right? To minimize the error, to make the surface fit these green dots, the particular realizations, in the best way. Yeah, so that's response surface methodology. Okay, now let's sum it up. So metamodeling is a very broad concept that represents just a study of input and output relations. Metamodels are of many types and have diverse applications. And response surface methodology is the common polynomial-based metamodeling method. Okay. All right, and now I would like you to go to answer my question, just to verify that you have understood what I've asked you. What does metamodel do in regard to the model at issue? A, it improves it. B, approximates it. And C, verifies it. Okay, please go to govote.app and use this code. Yeah. All right. Now let's see. All right. Okay, we have B 80% and A 20%. This is number one. Okay. Right. This is, now I would like you to answer the second question. What defines a particular metamodeling approach? A, field of application. B, metamodeling method. And C, combination of metamodeling techniques. And again, please go to Go Vote. And yes. And you will, yes. Oh, just click refresh. Right. Right. So we have something similar. Yes. I plan to discuss it in pairs, but maybe we can skip this since we have the majority answering it very well. So these are two correct answers. Please, yeah, that I wanted you to answer. So yes, what does model do in regard to the model at issue? So yes, that was the first slide. I was talking about the approximation. So you had to remember that G, the meta model, was the approximation that we used, right? And most of you did it well. Yes. And the second question about what defines a particular metamodeling approach. I was trying to emphasize that approach, or in other words, method. This is confusing, I know, because of a lot of similar word techniques, methods, approach. But yes, what I wanted you to remember is that a particular approach, metamodeling approach or method, is being defined by a combination of metamodeling techniques. So for that reason, yes, C is the right answer.
But what does metamodeling method and
That-
combination of metamodeling techniques mean actually?
Combination of metamodeling techniques, that what defines a particular metamodeling.
Yeah, but
method.
combination of those techniques is actually method, right?
Yeah.
So
B could be
B or
a-
C could be
The
equal. then.
same.
No, but metamodeling, the metamodeling method and metamodeling approach is the same. So what defines the metamodeling method? Metamodeling method.
No, like I was confused between the meaning of
Yeah,
B and C.
that's what I meant. That's what I meant. It is confusing with this terminology, but I couldn't go around it. There is not even a word for it. I mean, they don't even name it. Something like that. That's a little bit of my invention. I called it a metamodeling method because nobody says anything. They call it metamodeling, and they classify it based on the techniques. That's what they call techniques. I couldn't
But
call
these
it
are not
steps.
techniques, they are steps, right? Because you have
I
to
call
follow
them
that,
steps.
right?
This is free. In the literature, they say techniques. So if you would have gone out and talked to people like, these are 3 steps, and people, well, I haven't read about the steps. These are techniques, aren't they? Yeah, so I totally agree. I would call them steps. I told you steps, right? But technically, they're identified as techniques. Yes. All right. So that was it. Thank you.
Thank you very much.